This conference will now be recorded.
Okay, now we can start. Our today's chapter is industrial hygiene air sampling. What is industrial hygiene? Industrial hygiene is prevention of ill health caused due to chemicals and air contaminants. In the air, there may be different contaminants like dust, uh, vapors. There may be volatile organic compounds, chemicals, and when these are inhaled, the skin of the worker is exposed. They may suffer from different types of the different types of the disease. The main focus of the industrial hygiene is this area. But our modern CIH, Certified Industrial Hygiene, do this job also. And in addition to that, certified industrial hygiene deal with the ventilation. He deal with the illumination problems. He deal with the biohazards. He deal with the noise. He will deal with the thermostat. Because because all these areas can have a negative impact on the health of the worker. It can affect the health of the worker. So therefore, certified industrial hygienists deal with the chemicals, deal with the bioagent, deal with the air contaminants, and also he can deal with all these areas uh, from health perspective point of view, from ill health effects point of view. Okay, next slide is about industrial hygiene sampling, that is duties of industrial hygiene. Our modern industrial hygienists perform four types of duties. When he is working as a consultant and if he wants to solve the problem of his client, then he will follow normally these four steps. First one, anticipation of the hazards. He will anticipate the hazards. For example, he can anticipate the hazard from okay, what type of facility he is going to visit, what type of operation will be there, what types of hazardous material will be there, and he can anticipate the hazard that he is going to meet, he is going to control. And second one step that he will follow, that he will perform, is the recognition of the hazard. Recognition of the hazard is performed by the walkthrough, by physical inspection, by walkthrough inspection, and it is a qualitative inspection. And by walking through the area, the industrial hygienist uh, recognize the health hazards of the chemicals, of the biochemicals, of the other areas which fall in his jurisdiction. And the third step that he will perform, that is evaluation of the hazard. Now he will evaluate the hazard. For evaluation of the hazard, he can perform, he can take air sample, he can conduct air testing, he can send the sampling to the laboratory, he can receive the reports, and then he can evaluate the hazards. This is mostly quantitative type of evaluation. This is statistical type of evaluation, and it can involve the different types of the sampling and testing equipment. And the fourth task that industrial hygienist should perform, that is control of the hazard. He will recommend, he will prepare a plan then how these hazards should be controlled. He can suggest administrative control, he can eliminate, he can look for substitution, and he can go for the engineering controls, and he will try to reduce the likelihood of the hazard and severity of the hazard, or he will try his maximum to reduce the exposure of the worker to the hazard. Actually, these are the four tasks, these are the four steps that industrial hygienist, which is working as a consultant, and he is going to the site of the client, he should perform these steps. Let me repeat. Number one, anticipation of hazard. Number two, recognition of hazard. And number three, evaluation of hazard. And number four, control of hazard. But the specific thing is that he will deal all the hazards which are related to chemical, biological agents, and these can affect the health of the worker. Okay, ji, any point, any questions so far, any point for discussion so far?
These are the industrial hygiene air sampling only mentioned here only for particular air sampling only. The way anticipating the hazards, the recognition of the hazard, the evaluation of the hazard, and the control of the hazard only for the industrial hygiene air sampling. Am I right?
Okay. Actually, this is the name of the chapter. That is, we are looking at in red
Yes,
color.
yes.
Industrial hygiene air sample. This is our chapter name. Here, the topic, the specific slide we
Okay,
are
okay,
discussing that the industrial hygienist duties. Who is working as consultant? Who will work?
okay, okay. Thank you. Okay, I got it. I got it. Thank you.
Okay. Now we will discuss some basic definitions. What is vapors? Vapor is the gaseous form of a substance which is normally liquid as substance at a room temperature. At normal temperature, liquid is solid or liquid. It's when at some higher temperature or it evaporates, its vapor are formed, then this physical form is called vapors. And then gases, we all know about gases. Gases is the physical state of the matter. A gas can occupy the area which is available, the volume which is available, and with the increase of temperature, the volume of the gas increase or pressure increases. And another definition, another term that is vapor pressure. Uh, when a liquid is at room temperature, then some vapors may leave its surface. There may be evaporation from a liquid. When these vapors, which are leaving the surface of the liquid, are in equilibrium with the atmospheric pressure, this pressure is called vapor pressure. Vapor pressure depends upon temperature. If we increase the temperature, vapor pressure of the liquid can increase. And particulate. What does mean by particulate? Particulate mean fine solid particles of the liquid or solid, such as dust particle, fog particle, smoke particle. The particle may be of solid, the particle may be of liquid. Both type of fine particles are included in particulate. And then dust. Dust is solid fine particle. Particularly a solid fine particle which are generated by mechanical action like crushing of stone, like grinding. Here, the particle size of the dust particle may range from zero point 0.1 to 30 micron. And next is the fumes. Fumes are the airborne solid particles formed by the condensation of vapor. For example, uh, vapors fumes evaporate when we conduct a welding operation. And these welding operation, due to condensation in the air, these become solidified. Then these are called welding fumes. Fume terms are mostly related to welding fume. And size particle of welding fluid may range from 0.001 micron to 1 micron. Remember, 1 micron means 10 raised to power minus 6 meter. 10 raised to power minus 6 meter. 10 raised to power minus 3 millimeter. And mist are the suspended liquid droplets generated by condensation or atomization. For example, when we push the water with pressure through a nozzle, when we uh, push the fuel, petrol, with the nozzle inside the chamber of the engine, then in the compressed air, it divided into small fine particles. And this process is called atomization. And this is called spray. Mostly, spray particles are formed whenever a pressurized liquid is discharged through nozzle inside the atmosphere. And the size of the mist particle may range from 0.01 to 10 micron. And the last one is fibers. Fibers particulate material matters होते हैं जिनकी aspect ratio may range from 3 to 1. Mean its length may be 3 times than its width or more than it. Then this type of the particle, this type of the contaminant can be termed as fiber. A possible exam question may be like this. For example, what are the particle size range of fumes? And the particle size range of the fume, very fine particle, that is 0.001 to 1 micron. And what is particle size range of dust? These are relatively bigger size particle, and these may be range from 0.1 to 30 micron. Okay, ji, any point, any question so far about this slide?
Farbai, what is this aspect ratio mean in the last
Aspect,
fiber?
aspect ratio is the ratio of length and width. Uh, yeah, like we say, when there is sphere, there is rectangle. All sides of the sphere are equal. But in case of rectangle, length of the rectangle is more than that of its width. At least if length is 3 times greater than its width, then such type of the uh, particles can be termed as fibers. मीन फाइबर्स की लेंथ ज्यादा होती है, लेंथ
Okay, good, understood.
more than 3 times of its width. Okay, next for next slide, types of air sampling. We can collect different types of the samples with different types of equipment. For example, there are grab sampling. In case of grab sampling, we capture a fixed volume of the air, like Tadler bags, light in a canister. For example, we have a plastic bag which has a fixed volume and we can seal it. The air contained in, for example, we can contain 1 liter air inside. This grab sample is such that we confine, we capture a fixed amount, a fixed volume of the air inside of paddle bag or inside of some other canister. So we may confine the air in a canister, in a container, in even small bottle, or more. Normally, these are direct reading instruments. These can show that their capacity is this, they are captured such volume of the air. And next one is our personal sampling. In personal sampling, the sampling equipment, for example, pump, that is worn by the worker. Worker wear that sample and he perform his normal duty. He can move from one place to other place. Actually, this type of sample is taken to measure the actually actual exposure of the worker to the contaminant. And other one is area sampling. We can also call it as a location sampling. In such type of sampling process, we obtained a sample from a particular location, a fixed location. We got sampling. Uh, the location of the equipment is fixed. And then there is integrated sampling. In case of integrated sampling, we collect a number of readings, we collect a number of samples. Uh, the most common example is time weighted average for example, time weighted average of noise time, where we get a reading at 8 o'clock, then 9 o'clock, 10 o'clock, 11, 12. At different times, we get the different types of reading. Then we calculate time weighted average to give it time weighted. This type of sampling is called integrated sampling, where we get a time weighted average at the end. And the last is direct reading instruments. Direct reading instruments are calibrated for specific contaminant. For example, we cannot reading of all contaminant. We cannot take sample of every contaminant here. For example, the most common example is our direct reading instruments. Direct reading instruments. For example, multimeter. In confined space, we measure concentration of hydrosulfide, we measure concentration of carbon dioxide, and it directly show the reading. The instrument directly show the reading. This type of the instrument use direct reading instrument or direct reading type of sample. In short, the summary of this slide is that we can have a different type of sample by different methods. There are graph sampling, in which we capture a fixed amount of air, fixed volume of air, and there are personal sampling in which pump is attached with the worker, and there are area sample where we get the sample from a fixed location, and there are integrated sampling where we get a number of reading, and then at the end we get time weighted average, and the last is direct reading instrument. For example, multimeter directly show the percentage of carbon monoxide or hydrogen sulfide inside the confined space. Okay, Ji, any point, any discussion so far about this slide?
Mr. Ghaffar, can you please repeat the lines of air sampling pumps, because I am just a little bit confused between the piston and bellows and the air sampling pumps. Kindly repeat it. Thank you.
In this slide, under which heading this fall? Area sampling?
Yes, yes. In area sampling, uh, yes,
No. No.
between area sampling and integrated sampling. I'm sorry, I am
Correct.
confusing between the area sampling and integrated sampling.
Okay, repeat your question, please.
Please elaborate the difference between the area sampling and integrated sampling, because in the sampling we use some instrument. So if the concept about the these two is clear, then we can use the instrument accordingly.
Yeah, okay, okay. Look, in personal sampling, worker measures the instrument and perform his duties. Okay. In area
Okay,
sampling, our instrument is stationary at a location. Worker do not mirror it. It is the instrument do not move here there. It is stationary at a location. In area sample, we
okay,
get the sample from a particular area, particular location. Okay.
okay,
In case of integrated sampling, we got a number of reading at different times, and then at the end we got and then at the end we get average of all these readings.
Okay.
Mostly time weighted average. That is called integrated sample.
I- Okay. Now
Okay.
clear. Thank you.
Okay. Next, why air sampling and testing should be performed? What are the reasons behind why we should perform air sampling and air testing? First one, for legal compliance. In some countries, there are laws that an organization must perform sampling, must determine the exposure limit. So, to comply for legal laws, to avoid the fines penalty from government agencies, a company must perform sampling and testing. And as comparison with standards of health, sometimes we intend to measure whether the concentration in our areas, in our workplace, is within the standard or it crossing the standard. It is within permissible limits or not. So we can't. So there is no way that we can assess. Only there is a way that we should perform a sampling, we should perform a testing. We will get a reading, then we can compare it with the standard with the limits. And the third reason is that assess workers' exposure. If we want to assess the exact exposure of the worker to a contaminant, then we have to measure. If we can't measure something, then we cannot control. Uh, exact exposure of the worker can only be calculated if we perform sampling. And if we get statistical result, then we can control it in better way. And next one is checking effectiveness of control. For example, uh, in some area we have uh, installed a ventilation system. How we can say that this ventilation system is effective? We have to take the reading before installing ventilation system, and then we have to conduct the air testing and sampling after installing the ventilation system. Then we can compare that how much concentration of the contamination in that has been reduced, whether this ventilation system is effective or not. And the last, client requirement, record keeping, maybe such type of the objective or purposes for performing air sampling and testing. Okay, ji, any questions so far? Any point of discussion about this slide? Ji, please give me feedback.
No questions.
Can I move forward? Should I move forward?
Yes, yes. Please go ahead.
Okay. Next topic is sampling methodology. How we collect the sample. What procedure we adopt to collect the sample? There are different methods available in the market. Uh, as far as David Jade book is concerned, he has recommended two references. One is Miosh Manual of Analytical Methods, and another one is OSHA Index of Analytical Methods. At which location, by using what instrument, in what case, what condition, which method we should use, we should consult NIOSH Manual of Analytical Method and OSHA Index of Analytical Method to decide which sampling method would be best. But there is no much detail of these references in the David Judd book. So far, we move forward. And next is AIHA accredited lab. The person who collects the sample and the laboratory who conduct the test, that should be accredited lab. That should be accredited from Association of Industrial Hygienists, America. Our person should be competent or lab should be accredited. And the next topic is equipment selection for sampling. There are number of equipment available to collect the sample. Uh, this is very important that we select the right uh, equipment to collect the sample. For example, we should consider the following factors when we are going to decide which equipment should be used to collect the sample. For factors, for number one, which contaminant, its size, its type, which method we are using, which accuracy we require. By considering all these parameters, we can select the sampling equipment. Okay, air sampling pump. Now we discuss different types of the sampling equipment. First one is air sampling pump. Most of the people are familiar with air sampling pump, in which there is a arrangement that's some pump suck the air, circulate the air with a constant flow rate, air move, pass through a hole and then on a filter. And we pre-weight the filter, post-weight the filter, and by applying formula, we can calculate the concentration of dust in the air. Mostly air sampling pumps are used for to determine the concentration of the dust in the air. And there are two types of the pump available. First one is low volume flow rate pump. Their flow rate may vary from 1 to 5 LPM. LPM stands for liter per minute. And high volume flow rate pump, their flow rate may range from 5 to 30 LPM. Here, we should remember that what is the flow rate of low volume pump and what is the flow rate of high volume pump. Such types of the questions are expected in the exam. 1.5 LPM and 5 to 30 LPM. And slide which topic which we are discussing is equipment, sampling equipment. A number of equipment are available for sampling. The first one we have discussed that was our air sampling pump. In air sampling pump, mostly there is a centrifugal pump. Centrifugal pump or centrifugal blower. However, to collect the sample, we can also use piston type or bellows type air pump. These are types of the pump. And such type of the pump, such type of the sampling equipment are mostly used in initial survey. In initial survey, mostly level of the quality is low, level of the precision is mostly low. Then there are direct reading instrument, that is the example multi-gas meter. And then there are pumps and cyclones. Actually, in case of cyclone move with the very high speed. It rotates itself, it rotates the air with a very high speed. And as a rotation of the high speed due to centrifugal force, so due to centripetal force, the larger size particles are discarded. For example, if we want to collect a sample of particular range of the particle, we don't want a particle greater than 4 microns, then we can use the cyclone. Cyclone will discard the air particle, this particle, which are whose size is greater than 4 microns. Next, our topic is sampling.
Jawad bhai, Ghaffar bhai, please go back. Yeah, this one.
Okay.
This Third one, please repeat this. The pump and cyclones again. Third one, third.
Pump and cyclone. In such type of equipment, we use pump and cyclone in combination. What's the function of pump? Pump circulate the air, pump to make some flow of the air. And what is the function of cyclones? Cyclones rotate the air in cyclone form, in helix form, in circular form. When air is moved with the high velocity in circular shape, then particles which are greater than particular size, these particles are discarded. These particles are separated from the air, and then we may be able to select particular size dust particle. For example, we have a sample in which there are dust particles. We know that dust one is inhalable dust and then is respirable dust. Inhalable dust is that whose particle size are very small and these can inhale inside the alveoli of our lungs. Very small size particle. But there are also large size particles. What we intend to select only small size particle. Then we use cyclone so that large size particle can be separated from the sample. Okay, I think no, it should be clear.
Yes, clear.
Our next topic is sampling media. Our sampling media may be filters. Our sampling media may be sorbent tubes. Filters are mostly used for dust, for particulate, for particles. There are different kinds of filters. For example, there are polyvinyl chloride filters. In short, we can say these are PVC filters. And there are MCF filters. These are called mixed cellulose ester filter. And there are glass fiber filter, matte weighted filter, tear weighted filters. There is not much elaboration or explanation of these filters in developed books. I think so. If someone want to study in some detail, he can search about filters on internet. And the other media that may be sorbent tube. In case of dust particles, we use filters. Filter can be filtered by the filters. What about gases and vapors? Gas and vapor can pass through the filters. Uh, for such type of contaminant like gas and vapor, we use sorbent tube. So sorbent tube are glass tubes in which a specific chemical is encapsulated. When we use this type of instrument, I would break the tube from one side and make the flow of the air inside the tube. And when air circulates through the tube, then the gas or vapor reacts with the chemical which is inside the tube. And this type of tube can show the reading. Which is the concentration? Which one is the concentration level of the gas or vapor inside that room? And next one. Okay, please, can you give me 5 minutes? Hello.
Yes. We can take. I think here is a Maghrib time. We can take 5 minutes break.
Okay. I think we can take 10 minutes break. After 10 minutes, we should then. No, what's the exact time right now? It's 18. I think at 30 we will be back. Okay, Ji?
Okay.
At 30 we will be back and rejoin the meeting again. Okay, Ji, Allah Hafiz.
Dear WhatsApp, I can't hear the voice. Hello, I can't hear the voice. I can't hear your voice.